In episode 30, titled VLAN Segmentation, What It Solves and Common Design Traps, we treat virtual local area networks as simple segmentation using switches and tagged traffic because VLANs remain one of the most practical tools for organizing trust boundaries at Layer 2. The exam often includes VLANs because they are familiar, but it tests whether you understand what VLANs actually solve and where people misuse them as a substitute for real security policy. VLANs can reduce noise, reduce accidental exposure, and make network intent clearer, but they do not magically enforce least privilege by themselves. The value of VLANs shows up when they align with roles and when they are paired with routing and access controls that govern traffic between segments. The traps show up when VLANs proliferate without purpose, when trunks are mismanaged, and when teams assume that separation at Layer 2 is enough to stop lateral movement. The goal in this episode is to make VLAN decisions feel like architecture, not like cable labeling, and to make the common failure patterns easy to recognize in scenario questions. Before we continue, a quick note: this audio course is a companion to the CloudNet X books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A VLAN separates broadcast domains, reducing noise and limiting exposure. Because devices in one VLAN do not automatically see broadcast traffic from devices in another VLAN. Broadcast noise matters because many discovery protocols and background traffic patterns are broadcast or multicast heavy, and large flat broadcast domains can become noisy and harder to troubleshoot. By separating broadcast domains, VLANs reduce the scope of that noise, which improves stability and reduces the chance that accidental discovery traffic reaches devices that should never see it. Limiting exposure also matters because many unintended interactions happen simply because devices share a Layer 2 domain, such as accidental file sharing, unintended service discovery, or simple lateral scanning that becomes easier in a flat segment. VLAN boundaries create a natural segmentation line that can be used to enforce role-based design, such as keeping guest devices separate from corporate endpoints. In exam scenarios, when you see limit broadcast or separate guest from corporate, VLANs are often the implied mechanism. The important point is that VLANs provide containment at Layer 2, but meaningful security still depends on how traffic is routed and filtered across VLAN boundaries. Access ports versus trunk ports are core VLAN concepts, and tagging matters because it is how multiple VLANs share the same physical link without becoming mixed. An access port is typically associated with a single VLAN, and endpoints connected to it send and receive untagged frames that the switch associates with that VLAN. A trunk port carries multiple VLANs between switches or between a switch and another device, using tags to indicate which VLAN each frame belongs to. Tagging is what keeps VLAN traffic logically separated on shared uplinks, and mistagging, or inconsistent trunk configuration, is a common source of leaks and outages. Trunks are powerful because they reduce cabling by carrying many VLANs over one link, but they also increase the need for disciplined configuration because a mistake on a trunk can expose multiple segments at once. In exam terms, when the scenario involves multiple switches, uplinks, or carrying multiple departments over shared links, trunk behavior and tagging are often central to the correct answer. Understanding the difference between access and trunk roles prevents you from placing a user endpoint on a trunk accidentally or forgetting that trunks must be constrained intentionally. A good practice is to assign VLANs by role, not by convenience or location, because role-based segmentation creates consistent policy boundaries that remain meaningful even when users move or when sites expand. Convenience-based VLANs often grow organically, such as this floor VLAN or this closet VLAN, and they can become meaningless for security because they mix devices with different risk profiles and different access needs. Role-based VLANs reflect what devices are and what they should be allowed to do, such as corporate endpoints, guest devices, voice devices, printers, servers, and management interfaces. This alignment makes policy easier because access rules can refer to roles rather than to arbitrary location groupings. It also makes troubleshooting clearer because if a device is in the wrong VLAN, its role is misclassified, which is a simple diagnosis rather than a mystery. In exam scenarios, when the prompt emphasizes limiting access by function, VLAN by role is often the best answer because it supports least privilege more naturally. The key is that role-based VLANs are not perfect security, but they provide a stable structure for applying security controls consistently. Inter-VLAN routing is required whenever devices in different VLANs need to communicate, and where you place gateways determines both performance and control. VLANs separate Layer 2 domains, so communication between VLANs requires a Layer 3 decision point, which is typically a router or a Layer 3 switch interface acting as the default gateway for each VLAN. The gateway placement is a design choice because it determines where traffic crosses the boundary and where you can apply inspection and policy. If gateways are centralized, you can enforce policy consistently at a core control point, but you may create bottlenecks and add latency for local traffic. If gateways are distributed closer to access switches, you can reduce latency and reduce core load, but you must ensure policy enforcement remains consistent across multiple locations. In exam terms, when the scenario includes inter-VLAN routing or devices in different VLANs must communicate, the correct answer often involves placing gateways at a controlled point and pairing them with access controls. The important lesson is that VLANs alone do not control inter-VLAN communication. The routing boundary does, and that boundary should be treated as a policy enforcement point. Access control lists and security groups complement VLAN boundaries because they control what is allowed across and within VLANs, turning logical separation into enforceable least privilege. VLANs create groups, but without filtering, routing can allow broad communication between those groups, which undermines the security benefit. Access control lists applied on switches or routers can restrict traffic based on source, destination, and port, which allows you to permit only the required flows between VLANs. Security groups, in environments where they exist, provide a similar concept at a workload or interface level, enforcing stateful rules that can reduce lateral movement even within a VLAN. The key is that VLANs create a structural boundary, while access control lists and security groups create policy boundaries, and both are needed for strong segmentation. In exam scenarios, answers that rely on VLAN separation alone to protect sensitive resources are often incomplete, while answers that pair VLANs with proper filtering align better with best practice. The design mindset is to use VLANs as a grouping tool and to use policy controls to enforce least privilege across those groups. This combination is what makes VLAN-based segmentation stick. A classic example is isolating a guest wireless VLAN from a corporate device VLAN because it illustrates how VLANs reduce risk without overcomplicating the design. Guest devices are untrusted, unmanaged, and often unknown, so they should not share a Layer 2 domain with corporate endpoints that have access to internal resources. By placing guests in a dedicated VLAN, you limit their broadcast visibility and their ability to discover or attack internal devices directly. Then you enforce routing and access controls so guest traffic can reach the internet but cannot reach internal services, while corporate devices can reach internal services according to policy. This also improves operations because guest problems remain isolated and corporate troubleshooting does not get confused by guest noise. In exam reasoning, when the scenario describes guest access, contractor networks, or public wireless, VLAN isolation is a common part of the best answer. The key is that the VLAN boundary is a starting point, and the routing and filtering rules make it an actual security boundary rather than just a convenience label. A native VLAN mismatch is a subtle pitfall because it can create leaks and confusing outages that look like random behavior, especially on trunk links. Native VLAN refers to how untagged frames are handled on a trunk, and if two sides of a trunk disagree on which VLAN is native, untagged traffic can be placed into different VLANs on each side. This can lead to traffic appearing in the wrong segment, unexpected reachability between VLANs, or intermittent connectivity depending on which devices send tagged versus untagged frames. The failures are confusing because some traffic is correctly tagged and some is not, producing partial success that hides the underlying mismatch. In exam scenarios, if a problem appears after connecting switches or after trunk changes and includes odd cross-VLAN behavior, native VLAN mismatch should be in your mental model. The best answer often involves standardizing trunk configuration and ensuring tagging behavior is consistent across links rather than making ad hoc fixes at higher layers. The main lesson is that trunk consistency is critical because trunks carry multiple trust domains over one link. VLAN sprawl is another pitfall because it increases complexity and weakens documentation quickly, turning segmentation into an unmanageable forest of small segments without clear purpose. When VLANs multiply without a strong role-based model, it becomes difficult to know what each VLAN is for, who owns it, and what policies should govern it. This leads to errors such as placing devices in the wrong VLAN, forgetting to update trunk allowed lists, or writing overly broad inter-VLAN rules because no one understands the intended flows. VLAN sprawl also makes audits and troubleshooting harder because logs contain many VLAN identifiers that do not map cleanly to business function. In exam scenarios, if the prompt mentions too many VLANs or complex segmentation that is hard to manage, the best answer is often to simplify by consolidating VLANs into meaningful role-based groups rather than adding yet another VLAN. The goal is to have VLANs that represent stable roles and trust zones, not VLANs that represent historical accidents. VLANs should reduce complexity by organizing it, not create complexity by proliferating it. Forgetting trunk allowed lists is a high-impact pitfall because it can expose sensitive segments widely by allowing VLANs to traverse links where they were never intended to go. Allowed lists on trunks limit which VLANs are carried across a trunk, and without them, a trunk can carry every VLAN by default depending on configuration. This creates unnecessary exposure because VLANs that should be local to a specific area can suddenly become reachable across the network, increasing the blast radius of misconfigurations and increasing the chance of unauthorized access. It also increases troubleshooting difficulty because traffic can appear in unexpected places, and it can make it harder to understand where boundaries truly are. In exam scenarios, when the prompt hints at sensitive VLAN accessible where it should not be, or unexpected reachability after adding a trunk, trunk allowed list issues are often the cause. The best answer typically involves tightening trunk VLAN membership and standardizing trunk configurations so only intended VLANs traverse each link. This pitfall is a reminder that segmentation is as much about limiting propagation as it is about creating separate labels. There are quick wins that make VLAN designs more sustainable, such as standardizing VLAN identifiers and naming across sites because consistency reduces mistakes and speeds troubleshooting. Standard identifiers mean the same role maps to the same VLAN number and subnet across locations when feasible, which reduces cognitive load for operations teams and makes policy templates reusable. Standard naming means device configurations and documentation use consistent labels, making it easier to understand what a VLAN represents without digging through tribal knowledge. This practice also helps with automation because consistent patterns are easier to deploy and validate programmatically. In exam scenarios, when the prompt emphasizes multi-site operations or the need to scale a design, standardization is often the best answer because it reduces long-term risk and makes governance easier. The point is not to obsess over the numbers. It is to ensure that VLANs are predictable, meaningful, and consistent across the environment. When VLANs are standardized, trunk configuration and inter-VLAN policy become more manageable and less error-prone. A memory anchor that fits VLAN design is separate, tag, route, control, and document VLANs because it reflects the sequence that turns VLANs into usable segmentation. Separate means choose VLAN boundaries that match roles and trust zones, creating meaningful broadcast domain separation. Tag means ensure access, and trunk ports are configured correctly so VLAN traffic remains distinct and trunk behavior is consistent. Route means place gateways and inter-VLAN routing deliberately, because routing is where boundaries become policy enforcement points. Control means apply access control lists and security group-like policies to enforce least privilege across VLANs, rather than relying on VLAN separation alone. Document means maintain clear mappings between VLA identifiers, subnets, roles, and owners, because without documentation, segmentation degrades into confusion. This anchor also helps you diagnose issues because many VLAN problems are failures of tagging, routing, or documentation rather than failures of the applications. When you can recite this anchor, you can reason through VLAN scenarios methodically and pick answers that strengthen both security and operability. To end the core, choose a VLAN plan for 3 departments and justify it in terms of role-based segmentation and controlled inter-VLAN access, because this is how exam scenarios often frame the question indirectly. A good starting point is to create separate VLANs for each department's endpoints if their access needs and risk profiles differ, and then define what shared services and cross-department resources must be reachable. If departments must share certain internal applications, you route through a controlled gateway and apply access control lists that permit only required ports and destinations rather than allowing broad inter-VLAN communication. You also keep shared infrastructure like printers or collaboration services in dedicated service VLANs with controlled access rather than scattering them across departmental VLANs. Trunking between switches should carry only the VLANs needed in each area, and VLAN identifiers and names should be consistent across sites to reduce confusion. The intent is to separate roles and reduce unnecessary visibility while still enabling the required business flows through clear policy boundaries. In exam terms, the best answer usually includes both VLAN separation and controlled routing rather than treating VLAN creation alone as the solution. In the conclusion of episode 30, titled VLAN Segmentation, What It Solves and Common Design Traps. VLANs provide simple segmentation by separating broadcast domains, reducing noise, and limiting accidental exposure. But they must be paired with routing and policy controls to deliver real least privilege. You understand access ports versus trunk ports, and why tagging and trunk configuration discipline are essential. And you assign VLANs by role rather than by convenience to keep segmentation meaningful over time. Inter-VLAN routing and gateway placement determine where boundaries are enforced, and access control lists and security groups complement VLANs by restricting traffic across segments. You avoid traps like native VLAN mismatch leaks, VLAN sprawl that erodes documentation and governance, and forgetting trunk-allowed lists that expose sensitive VLANs widely. You gain quick wins by standardizing VLAN identifiers and naming across sites, so operations and troubleshooting remain manageable. Assign yourself one trunk validation rehearsal by narrating how a trunk should be configured between two switches, including which VLANs are allowed, how tagging is handled, and how you would confirm that sensitive VLANs are not traversing links they do not need, because that habit prevents the most damaging VLAN segmentation mistakes. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.